Good morning, ladies and gentlemen. We're going to start tackling the remainder theorem as the last part of section 6.3, so we can move on. The remainder theorem helps when you're evaluating. It also helps figure out factors of polynomials. If I were to evaluate this, now evaluate hopefully you remember means just plug in. So when you evaluate this, we're not going to be doing this, so do not write down anything I do in blue, okay? Anyway, if you're evaluating, you would put in a 2 here and a 2 there, and you evaluate it, okay? So this would be the opposite of, now 2 to the third power is 8, 6 times 2 is 12, so negative 8 plus 12 is 4, and then 4 minus 7 is going to be negative 3. Now, that's for evaluating it by substitution. We're not doing that today. What we're going to be using today is synthetic division in the remainder theorem to evaluate, okay? So, first thing we do, synthetic division, is I have to look at this polynomial. And hopefully you realize it goes from 3 to a 1. So if I'm talking about my coefficients, I have a negative 1, and then I have a 0. Super important because there's no x squared term. Then I have a 6, and then I have negative 7. Now, you might be saying at x equals 2. Okay, well, I should go back and show you this. That's what we're finding, f of 2. So then since x equals 2, I'm just going to drop that 2 in here. So using synthetic division to evaluate, this is what we do. We just do it. So negative 1 times 2 is negative 2. We add, we get negative 2. Negative 2 times 2 is negative 4. We add, we get 2. 2 times 2 is 4. We add, we get negative 3. What? Those are the same. So instead of doing all this work, right now what we're going to be doing is using synthetic division, and we're going to be circling that. Because the remainder there that we normally get is the same thing as what you get when you evaluate it using substitution. Okay? So what we're doing is this part over here. We're using synthetic division, and the remainder is going to be the remainder. Now, if this were 0, that's a different story. And we'll get into that, what that matters later. Okay? So 1 down. Okay. Now number 3, something similar. We're just going to use synthetic division here. Oh, hello. We're going to put negative 3 in the box. And then here, I have a 3, 2, 1, and a 0. So I'm just going to go 1, 3, 2, and 8 with the coefficients. So then I drop the 1. 1 times negative 3 is negative 3. We add, we get 0. 0 times negative 3 is 0. We add, we get 2. And 2 times negative 3 is negative 6. We add, we get 2. So if I were to take a is equal to negative 3 and plug that in here and substitute, I would end up with 2 from right there. All right? That's what you get. That's all there is to it. Next up, we're plugging 7 in the box. Let me change the color here. Don't really like red that much. I have a 5. I don't have a 4. I'm missing the x to the 4th. So I have 1, 0 for the placeholder there. And, almost put a 3 there. That'd be a bummer. Coefficients negative 47. And then negative 16. And then 8. And then 52. All right, so big one here. Drop the 1. 1 times 7 is 7. Add, you get 7. 7 times 7 is 49. We add, we get 2. 2 times 7 is 14. We add, we get negative 2. Negative 2 times 7 is negative 14. We add, we get negative 6. And then negative 6 times 7 is negative 42. We add, we get 10. So our remainder here is 10. And so that's what we get when we substitute 7 in for that function, or f7. So f of 7 is equal to that. You can definitely write that. Good answer. All right, now it says state if the binomial is a factor of the given polynomial. Now, before we start these, state if the given binomial is a factor. So these are all yes/no questions. Yes or no. Is it a factor or is it not? So how we're going to get that is the remainder. If the remainder is 0, then it is a factor. Okay, it goes in evenly. If the remainder is something else, no, it's not a factor. So it'd be like saying this, 12 divided by 2 is equal to 6. Is 2 a factor of 12? Yes. What about 12 divided by 7? That's equal to 1 and 5/7. Is 7 a factor of 12? No, because there's a remainder. So, here we go. I'm going to plug in. Now, don't forget, if k minus 2 is what we're dividing by, we're going to plug in 2 into the box. Once again, k minus 2 is equal to 0. We add 2 to both sides. We get k equals 2. That's what we plug in right there. Then we get the coefficients. So I got 1, -1, -1, and -2. Didn't have to put a placeholder because we got 3, 2, 1, and 0 up here. So now, we'll drop the 1. 1 times 2 is 2. We get 1. 1 times 2 is 2. We add, we get 1. 1 times 2 is 2. We add, we get 0. We did not get a remainder. If we're going old school, going back a couple sections, then I know that my answer would be k squared plus k plus 1 from right here. Drop down a degree, and there's no remainder here. Since there's no remainder, we would write yes. So, in these questions, you need to show the synthetic division, show the remainder, and then interpret that and either write yes or no, depending. Okay? Next one we're going to do is number 10. All right, now number 10, what goes in the box? P plus 5, so I'm going to put -5 right there. Because if I set that equal to 0, we'd subtract 5. All right, now I got 4, 3, 2, 1. Okay, good. So I don't have to have any placeholders. 1, 6, 11, 29, and -13. So I'm dropping the 1. 1 times -5 is -5, we get 1. 1 times -5 is -5, we get 6. 6 times -5 is -30, we get 1. 1 times, sorry, -1. -1 times -5 is 5. We add and we get -8. Okay, we didn't get 0. So technically my answer would be p to the third plus p squared plus 6p minus 1 minus 8 over p plus 5. Don't have to write that. Since that's not 0, we write no. It is not a factor. Didn't come out evenly. Now, number 12 is the next one we're going to work on. In the box, I'm going to put a -5 because that's the same thing we did in the last one. Here I have 5, and then I have 3. So I need a placeholder for my 4. So I have 1, 0, -25, -7, -37, -18. There's 1. 1 times -5 is -5. We get -5. -5 times -5 is 25. We get 0. Okay? 0 times -5 is 0. We get -7. -7 times -5 is a positive 35. We get -2. And then -2 times -5 is a positive 10. We add and we get -8. This is not a 0. That means that we would write no. Out of curiosity, just so you know, this answer would be n to the 4th, because we dropped that a degree, minus 5n to the 3rd, so n to the 4th, n to the 3rd, n squared, n. So then this is gone. I get minus 7n, minus 2, and then minus 8 over n plus 5. But we don't have to do that. This question's only asking, is it a factor or not? So we plug it in. We got a -8 here. So no, not a factor. All right, I think this is the last question. Could be wrong, but who knows? I got -2 in the box. So I'm going to set that equal to 0. You'll figure out why I put that in the box. I don't need a placeholder because I got 4, 3, 2, 1, and 0 here. So 1, 10, 21, 6, -8. And let's get into it. Drop the 1. 1 times -2 is -2. We add, we get 8. 8 times -2 is -16. We add, we get 5. 5 times -2 is -10. We add, we get -4. -4 times -2 is a positive 8. We add, we get 0. Awesome! That means, ladies and gentlemen, that we can write yes because it is a factor. So I would need to see all of this for your work. All right, now understand the answer is, and the quotient would be n to the 3rd plus 8n squared plus 5n minus 4. No remainder, so yes, n plus 2 is a factor. The homework is going to be complete the rest of the front side, and that's it. Have a great day.